we're going to dive into objects, functions, and the execution context. JavaScript is based in objects. It's an object-oriented language. Basically, everything that we do in JavaScript is an object. Every data type that we have is inherently an object. When you are trying to manipulate the DOM in your web browser, it's an object. Like, objects are everything when it comes to programming. So tonight we're going to kind of dive into how those work in JavaScript, how we put information in, how we extract information out of objects. And functions, basically functions are what make JavaScript do things, right? So objects are a way to store data. Functions are a way to do stuff with that data. That's really what it comes down to. And the idea of JavaScript, and we'll go into more as to like why, is to, you create functions to limit the need to rewrite the same exact code. You create a function that does one thing, and then anytime you need to do that one thing, you just call the same function, right, that we've already created. We don't want to have to like type out the exact same thing over and over and over again. And the execution context is basically the space that all of our code is running in JavaScript. When we invoke a function, we get a local execution context with its own memory, and all of that lives inside of a global execution context. We'll kind of dive into as we get into each specific piece. So, JavaScript is the tool of the web. The modern web page, web application, it's really hard to call anything a web page anymore because it's, 20 years ago, a web page was literally that. It was just kind of like a piece of paper displayed in your computer screen. It just kind of displayed information and didn't do anything. These days, those pages don't really exist. Every web page is its own application. It's doing stuff in the background. And JavaScript is what makes it do that. So the web is basically built of three different things: HTML, CSS, and JavaScript. I like to use the analogy that HTML, if you think about like a car, HTML is the frame of the car. It's basically just the structure, how everything is kind of like set up. CSS is cascading style sheets, and these two things are what we'll go into next week in the class. This is what, tells us what color we want the car to be, what kind of rims we want on the car, all the little kind of like the looks, basically how we want to make it up. And JavaScript is what makes the car do all the things that we want a car to do. We want a car to drive places. We want to listen to the radio in our car. We want to roll the windows up and down. JavaScript is the functionality that makes our car do stuff, right? A wobbly table, and I'm going to spill my tea before the end of the night here. All right, so let's just dive right into it. So we're going to, first slide is basically just kind of talking about what happens when JavaScript code runs. And JavaScript is a synchronous language. So basically, it can only run one line at a time. So the engine goes through the code line by line, saves information as data. We use special declaration keywords that we'll talk about. This allows us to reference, change, and run functionality on our data later. But before we can do anything with that data, we have to store that data to some kind of value, right? So when we run our code, we create a global execution context, which for the purposes of tonight, this whole whiteboard is going to be our global execution context. Along with the global execution context, we get a global memory, which is where we'll store all of our variables in our global memory so that they're just there, right, whenever we need to access them. It's kind of like if you have a bowl of keys at the house. Like you always know where your keys are because you leave them in the same place. So anytime you need a key, you go to the key bowl, you get it out. It's the same thing. Anytime you need access to data, you know that you store it in your memory. So you just go to your memory, you get it out. We are out of chairs in here, but if you want to grab a chair right there, you can pull up right behind Svetlana there if you'd like. Oh, you won't be able to see anything. There is one back here, but it might be a little tight to get to. Your best bet is just to pull up a chair right there, to be honest. Packed house tonight. Okay, so, I forgot to get my good markers. As I said, our global execution context. So for the purpose of tonight, this whole board is our global execution context. And with our execution context, we have our global memory. All right. So any brave volunteers that want to tell me what we're going to do on our first line of code here? Remind me your name more. Usman, right?
Usman.
Okay.
Yeah. We're declaring a variable myGrades, and we're assigning it the array 50, 75, and 100.
50, 75, and 100. And what kind of variable is that?
It's a constant.
It's a constant, which means what?
That it's unchanging, it's immutable.
Exactly. It's constant. So we can't alter this. We can't change this to another array or a string or something else. Like once we declare something as a constant, it is exactly that. It's constant. So next line of code. Latif? Alisi. Yes. Okay. And where are we going to put that?
Is that the global? Yeah.
It's going to go in our global memory. Exactly. So we have these two variables in here. Now, last week we talked about loops. Is there anybody that's not familiar with how a for loop works?
Oh.
Huh? What is a let? Okay, yes, okay. So these are two different ways that we have of declaring variables. We have const and let. We also have var, which is something you might see a lot out there, especially in older code, but it's not really something that's used so much anymore. As of ES6, which came out in 2015, it's the most standardized version of JavaScript that we use at current time. And it brought along const and let, which basically allows us to scope our variables so that we only can access them in the scope of our function or of our whole entire application that we want them to be accessed in. We don't want to alter our variable somewhere else accidentally. So we use let and const because it maintains a scope, and we'll get into more of how that works as we go through the night. But for now, just know that anytime we use const or let, we're declaring a variable. And so by doing that, we're storing the name, myGrade, and sum in our global memory, and we're giving them the value of anything that's on the right-hand side of that equal sign. So we're setting a name of our variable and a value. So on the left of the equal sign is the name of the variable. On the right-hand side is the value that we're assigning to that variable. So now we're going to go through a for loop here, and I'll basically, whenever we do this, go through just basically what happens. First, we're going to declare let I equal 1. Or I equals 0, I'm sorry. So we're going to do this once. So when we do this, we're saying let, so we're declaring a variable, and we're assigning it to 0. The next thing we're going to check in our for loop is I is less than myGrades.length. So now we're going to check if I is less than myGrades.length. So myGrades is this array we determined, right? So by putting that .length on the end of it, it's basically just going to give us the number of elements inside of that array. So for the purposes of this, what is myGrades.length?
How many characters?
How many elements are in myGrade? Which is 3. Exactly. So anytime we're saying myGrades.length, it's 3 for this purpose. If we added something else to that array, it would be 4 or 5 or 2. However many elements are inside of an array is a number that you get when you hit that .length, right? So then you would think we're going to go straight to this I++, which is what increments our counter. So, but it's not actually true. We're not going to do this until the end. We start with the for let I equals 0, and then we're going to check to see if I is less than myGrades.length. And then, if so, we're going to do this, which is sum equals sum plus myGrades bracket I. And then after that, that's everything. So this is basically when we open this bracket, this is telling us what we're going to do inside of this loop. So anything that has these two slash marks in front of it is a comment. So basically a comment is just there for us to see. Or if somebody else comes in to read your code, you can just like leave a little note for them. But it's not going to actually run that code. So that,
why does I++ not happen until you run the code inside?
so this is just like the syntax of a for loop. And I'm going to get the rest of it up on the board and we'll walk through like how it works. But basically, there's three parts within our parentheses when we declare our for loop. First thing, we declare our incrementer, which is what we're going to increment so that we know when to stop, right? The second thing is our condition, which as long as that condition evaluates to true, we're going to continue running our loop. And we're just going to go over and over and over again. At the end of the loop, we're going to use the incrementer, which in this case is I++. It's pretty much the standard like incrementer for a for loop. There's lots of different ways that you can do. Maybe you want to skip every other thing inside of your array. You do, I plus equals 2 or something like this where you increment it more. But plus plus basically just means we're adding 1 to the value of I. So every time you see I++, whatever the value of I was, which right now it's 0, if I say I++, I becomes 1. We change that value, we reassign it. So inside of our loop, the only thing we're actually doing, because everything else is commented out, is sum equals sum plus mygrades I. So mygrades I, if you weren't here last week, and you're not familiar with how arrays work, so arrays are 0 indexed. So when I say mygrades and I put those brackets there, I'm going to put a number inside. In this case, I is evaluating to a number, right? So that's going to tell me which thing of that array, which element of that array is it that I'm actually trying to add to, right? So arrays are 0 indexed. Everything in JavaScript, when we're counting something, it's all 0 indexed. We don't start at 1. We start at 0. So these indexes aren't 1, 2, and 3. They're actually 0, 1, and 2. And this goes for pretty much, I think it goes for most programming languages. Definitely everything you're going to do in JavaScript is all 0-based index. So what that means is, currently, if I is 0, and I say mygrades bracket 0, what is that going to give me, Ian?
It's going to give you the first element, which is 50.
Which is 50. Excellent. Perfect. So basically, now we're going to, at the end of this, after we've done everything that's inside of there, then we're going to do I++. So as we walk through this really quick, Ian, you want to walk us through this for loop really quick?
Okay. So you have I equals 0, which is 50. So sum would be sum plus.
But before we do that, we've got to check this here, right?
Yes.
So what are we checking?
We're checking to see if 0 is less than mygrades.length, which is true.
Yep.
And then we're going to sum.
Okay.
And it's going to be sum plus mygrades 0, so it would be sum plus 50.
So 0 plus 50. So we have currently sum is 0, and mygrade 0 is 50, right? So now we change new value of sum to 50. Okay. What's next?
Then you'll increment by 1.
We're going to change I to 1. Okay.
So now you're checking to see if 1 is less than mygrades.length.
And 1 is less than 3. So go here.
So then we're doing sum equals, now it's going to be 50 plus 75.
Okay. So we're going to change sum to 125. And then?
And then you're going to increment by 1 again.
Okay.
And then you go back to see if 2 is less than 3.
Which it is.
So now you're doing sum equals 125 plus 100.
Okay.
And you'll increment again to 3.
Okay.
And 3 is not less than mygrades.length, so it terminates.
Exactly. So basically, as you can see, we set our incrementer at 0 because we're going to start at 0. We're going to do some stuff in the middle of there, and at the end of each iteration, we're going to increase that incrementer. And we're basically going to use this check, this I equals less than migrades.length, and we're going to continue this loop over and over and over again until I is not less than migrades.length. So when we get to 3, 3 is not less than 3. It's equal to 3. So that's it. We've stopped our loop. Loops are one of the cornerstones of any programming language. I mean, we live and die by data. And basically the way we iterate through data is by looping. You know, we do something on one piece of data, and we move to the next, we move to the next. This is all looping. Okay? Did you want to grab a chair right here if you want to join? Okay. Yes, you can.
Would a for loop never have a return statement because it has the conditional of when it should terminate on its own?
So we'll get more into how functions work later, but a for loop could have a return statement but it would most likely be inside of like a conditional. Because once you hit return, you exit the execution context, right? So you can only return from a function. We haven't actually started a function here. But you could have a for loop inside of a function that returns if a certain condition applies, which we'll talk more about functions and that stuff later on in the evening, for sure. Do you have a question?
Can you use int-stream in JavaScript?
What's that?
Can you use int-stream in JavaScript?
Int-stream? What language is that from?
Java?
Java. I'm not familiar with it, so there may be something similar. How does int-stream work?
It's basically an internal Java that basically does the exact loop. So you have like int-stream of migrades.sum.
Okay. So basically, there are some higher order functions that we go into in some of our other classes, which are different ways of iterating through in a much less verbose way. But everything that they're doing under the hood is this exact situation. So for the time being, we're just worried about like how basically a loop works. Yes.
Can you repeat what you said about loops? Can you repeat what you said about loops? It's the basis of.
It's just how we iterate through data. So any kind of like data that we have, we want to do something to every piece of data, or maybe we have like if this data, passes this test, then we want to do something. But any which way, the only way to get through a series of data is to loop and move your kind of incrementer throughout whatever the data set is that you're going through. And there's no limits to what the data could be that you're going through. There's no one set thing that data is. All right, who? Remind me your name. Yes. Remy. What's the next line of code on our screen?
Sum equals sum plus migrades.
We already did that. We already did the loop. So we ran through our loop, right? So we got to there. So now we're coming down here.
But average equals sum.
Okay. So the first thing we're doing, what is average?
Average of
Well, what is average? Like,
definition of average.
no, what is? It's a variable.
It's a variable.
Exactly. So we're declaring a variable that we're going to put in our global memory, average, and we're setting it equal to.
Equal to the sum divided by migrades dot line.
So we have 225 divided by 3. Anyone? 71? 75. 75. Ooh, that's a nice easy number. I should probably know that. I've done this class enough times, I should know that by now, right? So yes, that's what happened. And basically now we've gotten to the end, so our execution context is complete. So we use our global memory to store our variables, and then we can access them in our execution context however we go through our data, right?
Excuse me.
Yes,
This is like irrelevant to what I'm currently doing, so thank you.
no problem.
Why is I part of the global memory just inside?
Well, we don't have so I here is just in this for loop, right?
Yeah.
So in order to open up another local execution context, we need to have a function, right? We haven't opened up a function yet. So everything right now is in our global memory. So, start over here. So, what if we wanted to do that average, but we didn't want to have to like write it out every single time as that like for loop, right? This is where functions come into place. So, we create functions so that it's the kind of the concept of dry. Don't repeat yourself. So basically we're going to write functions so that when we want to do something, we can just pass this function and call it every time we need it to do something instead of having to write that code out every single time we want to create an average of an array, right? So now we're going to open up a function, and it's called average my grades. So when we create a function, now we have our global execution context. When we create a function, we're going to create a local execution context. And we're also going to create a call stack. These are also two kind of the cornerstones of JavaScript. So we're going to just say within our global execution context,
So memory only becomes local when you in a function?
yes, every execution context has its own local memory.
Okay.
So technically, the global memory is the local memory of the global execution context in reality. But for our purposes, it's the complete outer shell. There's nowhere to go outside of it. So we refer to it as the global execution, or the global memory. So now we're going to have a local execution context here. So now we have another, which is basically the exact same thing as the giant board, and now we just have an execution context that lives inside of our global execution context. And we're also going to add a call stack. So our call stack, as I said in JavaScript, we can only do one thing at a time. So anytime we open up a new function, right? So we're going to declare a function average my grades, which opens up this new execution context. So with that execution context, we have to add this execution context to our call stack. And the way a stack works, it's just like imagine a stack of books, right? If you put a book on top, the only book you can really take off is the one on the top. If you want to get to the one on the bottom, you got to take one off, take one off, take one off. Otherwise, everything's just going to fall apart. If you try and grab one out of the middle, all the other books are probably going to fall down. So basically in JavaScript, the only thing that we're ever working on is what's on top of our call stack. As we add things to the call stack, they'll go on top. When we're finished with those, we take them off the top and we move back down to the next thing. And this is how we keep track of what's going on. This isn't something that you see, there's no like, oh, where can I go see what my call stack is? It's just how JavaScript works under the hood. It's how it keeps track of what it's got to do. It's like a to-do list, if you will, but it can only be doing one thing at a time. So it's always doing what's ever on top of that call stack. So if I open up another function inside of this execution context, I'm going to put another function on top of that. And I can't finish this function until I close the one inside of it out. And basically, so it just becomes this big accordion, if you will, and then you kind of just you knock things off the top until you get back down to 0. And that's when you finished your execution of your application. Yes?
This is real relevant. So I look at a definition of callbacks. I just want to know, I don't know if I get answers for this part of course, but in the scope of what you said about the execution process of the call stack, how do you implement a callback in that?
So basically, yes, you are correct. It's a little more advanced than where we're at tonight, and we do go into callbacks in some of our JavaScript, the hard parts. Basically, a callback is just a function that you do when you're done with what you're doing with. So your callback, you're like, hey, I'm going to do this, and then when I'm finished, I want to do this afterwards. That's how a callback works. But we got a lot of things to cover between there and callbacks. So we'll talk about that in one of our JavaScript, the hard parts, in the callbacks class. So basically, you'll recognize this code. It looks very similar to what we just went through, right? We're doing the same thing. We're declaring const my grades. We're doing sum equals 0. We've got our for loop that iterates through and creates our sum, right? We've done all this before. But now, where are we going to do all that stuff?
Inside the function?
Inside the function, which is here, right? So the first thing that we're going to do is declare average my grades as a function. Where am I going to put that?
So function being global.
The function, exactly. The function is in global. So over here, this is where I declare average my grades. And I'm setting that equal to, just going to put this function here, right? So what's the next line of code that I'm going to run here, Dylan?
Well, just like we did before, we're going to go by line 2, which is constant my grades. We're just going to check that array.
One would think so, but that's not actually true. So first we declared this function, and we basically just stored. When we say function average my grades, we're declaring a variable called average my grades, which is a function. So basically, we just store all of this information. From this curly brace all the way to the closing curly brace, that is the function definition. So when we declare a function, we just store the whole function into memory. JavaScript doesn't actually read that function, doesn't actually do that function until we call that function or invoke that function, right? So the way that we know how to invoke that function, as you'll see, we add parentheses to the end of it to say go. So anytime you see the word average my grades and with some parentheses next to it, that's telling JavaScript, now I want you to go do the stuff that's inside of that function. But when we declare it, we don't actually, JavaScript doesn't care because maybe we never even call that function. We can declare it, but we're not going to waste our time trying to go through what it is unless we're actually going to use it. Make sense? Yes?
You just said the term function definition. Can you break down when you supposed to use that term?
Yep. So basically when I use function, right, this keyword here, that means it's just like let or const. It means I'm declaring a variable, but that variable specifically is a function. So basically, I put that in my memory, and here I'm going into the global memory because that's where I am right now. So I put average my grades as a new variable, and it has a function. So the function definition, basically, what is in the function is everything. We see average my grades with these little curly braces, and then this open brackets here. So this is how we know it's a function. We say function, we have the name of the function, which becomes the name of our variable. And then we have these open and closed parentheses. Then we have the open brackets. Now everything inside of this bracket is our function's definition. It's like it's what's going to happen inside of our function, right? So as I said, we declare this as a function, but JavaScript never actually reads what's inside of it until we call it. So what's the next line of our code, Dylan?
So that's going to go down to the console log underneath the comment.
Exactly. So right now we're going to say console log my grades is plus my grades. So the console is something, we can represent that down here, that you have, if you're familiar with your Chrome DevTools, or if you've worked in Node or VS Code, you have a console that you can print things to. Yes, question?
Here's a question. Okay, so the console log is outside the function, right? But he has never read the function. Don't you have to call it first, or you would have to put, you repeat average my grade?
And that is why we are saying, what should we see here and why? So what's going to happen when we say?
Yeah, you're not going to see anything.
Yes. We're going to get an error, right? Yeah, because my grades does not exist.
Exactly.
As far as the global execution, any kind of thing that it's pulling from, if I say my grades, it's going to look over here in the memory. My grades doesn't exist yet, right? And my grades doesn't exist and will never exist in the global memory. So now we get down to the next line of code. Remind me your name? Latifa. What's the next line of code?
We declare a variable called output equal to average my grades. That we call a function.
So we're setting it equal to whatever average my grades returns, right? So in order to store that value, I've got to go do something, right? So what am I going to set the value of output to until I know what I'm going to set it to.
You have to return. You have to return the function.
We have to return the function, but while we're running the function, what is the value of output? Alicia.
Undefined.
Undefined, exactly. So we declare output when we say const output, but now we have to go run this function before we can actually get its value. Yes?
I'm confused. Why are you storing the function average migraine and output? Like, why is that happening?
So basically, we want output to be whatever comes out of our function, right? So we use the function to run this through. So what we're going to do, we set output in our global memory, but for now, it's undefined because we've declared it, but we don't have a value for it yet. We got to go do something to do that. So when we do that, now we're going to add average my grades. I'm erasing my call stack here. To the top of our call stack, and we open up this local execution context. So, column.
Yeah.
What's the first thing we're going to do inside of our local execution context?
You're going to declare a local variable, the array migrates.
Okay. And 100. Next line.
Declare the next one, sum
Okay.
equals 0.
Okay.
Then
Keep going.
Then we're going to establish a loop.
Okay. What's the first step we do in there?
We have to actually declare I to be 0.
Put that here, right?
Okay.
Next.
The next part of that is check if I is less than the length of my grades, which is 3.
Okay.
And then the next step, once you go through the loop, will be to increase I by 1.
Okay, but what are we going to do inside of the loop?
So inside the loop, you take sum, which is now equal to 0, and add my grades bracket 0.
My grades I plus sum. I think I wrote that backwards.
Wait,
now.
I'm
It was the
sorry,
same one.
It's going to be 50 plus 0. Yeah.
Break that down when you just said.
Yep. So it's the exact same thing that we did in the first slide. But now we're doing it in the local execution context. So first, we set I equal to 0.
0 is 50.
And then we're going to start our loop, right? So at first, we check if I is less than 3. I is 0, so it is less than 3. And this is actually, we'll write it out. So this is my grades dot length, which is 3, right? Because there's 3 things in my grades. So its length is 3. So first, we set I equal to 0. We check, is 0 less than 3? Yes, it is. So now we're going to change the value of sum to sum, which is 0, plus my grades I, which is 50. So now sum becomes 50. Now we say I plus plus, we're going to go up 1. Now we loop back up here. I is now 1, which is less than 3, so we continue on. So now sum equals 50 plus 75, which is 125. And then we increment I, so I becomes 2. We loop back up here. We check, is 2 less than 3?
Yeah.
Yes, it is. So we go back down again. So now we say sum is 125 plus 100. We go here, we change I to 3. We go back up here, is 3 less than 3?
No.
No. So we're done. So basically that ends our loop. Okay, so that's finished. The next line of our function, column,
So the function has to return some sort of value.
Value.
So we return this value, which is the sum, which we know is 225,
okay,
divided by my grades length, which is 3.
which you already have told us what that is. Oh, that was here. Which is 75. Okay, so now I'm going to return 75 now. Where am I returning that to? Column.
The global context.
Yep, but where in the global?
It'll be assigned to output.
Exactly. So this is going to go right over here. So output is no longer undefined. Output is now 75. We pop average my grades off the top of our call stack. And we close this execution context. And now we are back in our global execution context is on top of our call stack. Yes?
So I understood what happened in the local context, but can you go over how it's executed?
How it's executed? We're going to actually do it again right now, so you're going to get another chance to see. And I'll grab you and answer a question as we go through. Dylan.
Quick question. If you put like an if statement inside the for loop, does that change the call stack, or is it still only a function that changes the call stack?
The function changes the call stack. The if statement would just be a conditional that you check inside.
So it's a step, but it doesn't do anything.
Exactly, yeah. So, next line of code. Usman.
Declaring another variable, cons, and you're assigning.
What's the name of that variable?
New output.
Okay.
And you're assigning that variable average my grades function we just ran.
Okay, so what am I going to put in there?
75.
Right, but I don't know that, right?
Well, it's undefined.
You have to run it to the function.
I got to run the function again, right? So then for now, undefined. And so now I've called average my grades again. So I'm going to come over here, I'm going to put average my grades back on top of my call stack, and I'm going to open up. Anyone? What do we call this box? Local execution context. Exactly. And over here we've got our local memory. And over here we have our local execution context. All right. You want to walk us through how this works?
Sure.
I'll help you understand. What's the first thing we do inside of our local execution context here? Remind me your name real quick as well.
Nico.
Nico.
I'm not really sure. I'm sorry.
You're not sure? Well, give it a shot. We're going inside of average my grades, right? So now we're on this line right here.
So we look at the array, my grades, and then we look at sum. Are we doing the loop or the actual function?
We're running the function.
Okay.
So the first thing in the function, when we see const, what does that mean?
We declare constant, my grades.
Yep.
It's an array, 3 numbers, 50, 75, 100.
Okay.
Then we declare let sum number 0.
Okay.
Afterwards, we begin a for loop.
Okay. So what's the first step of our for loop?
We have we declare let I equals 0.
And where do I put that? Where am I storing I?
Local memory.
Local memory. Exactly. Got this. Next step.
Then we check whether I is less than the length of the array in my grades.
Okay. Okay, and what's going to be the third step?
We declare sum equals sum plus my grades I, and I is 1 at this point. We're doing it again, right?
Okay. Well, we're just declaring our steps right now. We'll walk through it next. What's the last thing that I do in my for loop?
We return division sum divided by.
Well, not yet. How do I know? When to stop my loop? So I go through here. I declare I equals 0. Then I'm going to check if I is less than the length of my array. Then I'm going to do stuff if it is, and then after I do that stuff.
The increment I.
Increment, exactly. I plus plus. And then from there, we just keep looping back through, right? All right, who wants to walk me through this? Omari. That's your name, right? Yes. So first off, I is 0. 0 is my grades. Dot length is 3. Yep, so 0 is less than 3, so that means I'm going to continue to line 3. So what am I doing on line 3?
You're adding,
I can write this all out.
Add the length of the array.
So we're not going to add the length of the array. We're adding the current sum, which is what?
0.
0. Plus my grades at the index of I, which is 0. So what's my grades at the index of 0, Mark? 50, exactly. So 0 plus 50, so we're saying sum equals 0 plus 50, which is 50. What do we do next? What's your name again?
Remy.
Remy.
We continue adding
1.
1.
Okay.
75. Yeah, 75.
So well, we've incremented I to 1. So then what's next?
Then
Check if the
We got to go back up and check, right? If 1 is less than 3. Okay.
what's 75?
Okay.
Which is 125.
All right. Next.
Then
Yeah, continue all the way through. Walk me through it. You got it. You're on a roll.
Then we increment another one, which would be the third one, third element, which is 100.
Okay, but what are we incrementing?
I.
Okay, so we increment I, and then we go
Check it.
back up to here.
And then sum plus, which is 125 plus 100, which is 225.
Okay, and then I'm so sorry.
And then we go and check it.
Okay, but we gotta do what before we check? We gotta increment. So now we go check.
Wait. Is 3 less than my base.life? It's not.
We're done. Right? So the next line of code that we're gonna run.
Call stack.
Well, we haven't closed our function out yet. We just finished our for loop.
Const output. No, const new output.
We already did that. Inside of our function, the last line of our function.
Return sum divided by.
Exactly. So we did our loop. So this loop is this for loop, right? So it's everything inside of these curly braces.
I jumped that.
No, no worries. No worries.
Return sum divided by migrate.line.
Which we know is 75.
75.
So we're going to return 75. And where am I returning that to?
new output.
To global.
Global. Over here at new output, right? Because that's why I opened it up. New output equals the return value of average migrants. So now we return that out. So we close out our execution context. And we pop that off of our call stack. So we're back to our global execution context. So now we've made output equals 75 and new output equals 75. So what's the main flaw in this function that we've written? Yes?
The console log?
Well, the console log still, like we determined, isn't going to happen, but that's not inside of our function.
Oh, inside the function? What's the main?
What's that?
Wait, repeat the question.
I just said what's the flaw in this function? Yes.
You can't add more grades, so the new output is always yield output.
Exactly. Every single time I run this function, I get the same exact output. It seems like a waste of time. Like, what if I want to run the average of a different set of grades? I still have to write the same exact function over again and just declare different stuff inside. Wouldn't it make a lot more sense if I could just say average my grades on any set of grades? So to do that, we move into parameters and arguments. So there's two different things here that we're talking about. It looks like the same thing, but they're different. So a parameter on this first line here, we're declaring the same function again, right? Average my grades. But instead of having an empty parentheses this time, we put grades inside of our parentheses. So what that means, that is a parameter. So what that means is whenever I call my function down here at the bottom, before I was just saying average my grades and I was just putting empty parentheses, right? But now I'm actually putting this array inside of that parentheses. So does anybody have any idea, like when I open up my execution context, what's the first thing that I'm going to do? Remind me your name one more time. Sorry.
Marcos.
Marcos.
When you say the execution context, you want us to know what the grade's going to do?
Yes.
All
So
right.
whenever well, let's just walk through it, right? So we have our global execution context. First thing we do, average my grades equals this great big function, right? What's the next thing that we do, Marcos?
All right. When you put average my grades like that, that array is going to be passed into the parameter grades, and that's going to run the function.
Exactly. So what's the second line of code that my function reads? After I declared this function, what's the next thing that happens?
When you call the function, you're going to read let sum, then you're going to read go to the root.
But have I called the function yet?
You did call the function because you put that inside of the parentheses already.
Right, but you didn't tell me that I called the function.
Those are const.
So yes, first we have to declare const output.
Oh no, I'm assuming it's already,
Yeah,
it's already
no,
there and everything.
we don't assume anything in Intro to
You want to go-
JavaScript.
yeah.
We look at things just like the computer does. The computer can't make assumptions. It can only do exactly what you tell it to. It's just it follows your rules one by one, line after line. So when we think about code, when we think about how to write code, we have to think about it the same exact way. So whenever we declare this function, we've done that. The next line of code is we declare this constant output. And what are we setting it equal to?
Undefined.
Undefined right now until so what do we do now? So we've called average my grades. What am I going to do now? Where do I run average my grades?
So it's gonna take the array that's in average my grades and then push that into the function.
Well, where do I do that? What do I need to put on my global execution context here? Local execution context, exactly. So I'm going to call average my grades. So I put it on top of my call stack, which makes me open up a local execution context, which in turn has a local memory. Starting to look familiar now, hopefully. All right, so now the first thing that's going to happen when I've opened up this execution context, Marcos.
Well, since we already declared the constant output and everything grades, and you put the array inside, that's going to be replaced by grades on top.
And so where am I storing that? Where does that go?
That's in the parameter, and it's going to be stored inside the function, right? In the local execution context.
The local memory.
The local memory.
So that means the first thing I'm going to do is I'm going to take that parameter grades, and this is where the difference between grades, parameters, and arguments. So grade is my parameter. What's my argument?
It's the array.
The actual array, exactly. So when I declare my function, this name or variable name that I pass in is my parameter. The argument is what I actually pass in as that. And so what happens, the very first thing when I run this function, I declare a new variable in my local memory, which is the parameter is the name of the variable, and the value is my argument, which should look very familiar. So, now I've declared grades equals this array. Yes?
And you had said the function gets stored in the global execution context. So why is it that the argument doesn't also get stored in the global execution context?
Why doesn't the argument get stored here? Because the argument only exists inside this function. So this function lives right here. I'll get you in just one second. Right here inside of the local execution context. So the actual definition of the function lives in our global memory. But every time we run it, we have to open up its own execution context to run it inside of. So when we declare grades, that only exists in this function. If I try to use grades outside of this function, what's going to happen? I'm going to get an error because it doesn't exist, right? Dylan, your question.
When it comes to arguments,
Mhm.
is it the data itself, or can you use like another variable? And it still is the argument, or is there that?
It's the data itself. If you pass,
So like for example, so my follow-up, if you took the array, said like let array equal that.
Okay.
And then if you put in grades, instead of like when you call it at the bottom, like
Mhm.
my grades, you said calling my array.
Yep.
Is that still an argument? Or is
so
that-
exactly, anytime you refer to a variable, what you get is its value. So when if I had like my array equals 50, 75, 100, and I pass in, instead of passing in this array, I say my array, it's going to say, oh, what's my array? It's going to come over here, it's going to be like, oh, my array equals 50, 75, 100. And then it's going to put that inside of the function.
So even though my array is that, that's not
Right. So if you can put an array in here, if you put just a variable name, then you have to have that variable stored somewhere. So it has to be able to access it in memory. It can't just like make guesses. Anytime you refer to a variable, it's going to look in the memory. So if you refer to it here, it's going to look here first. If it doesn't find it, then it's going to go outside. But you can never go inside. You can only look it's like the little Russian doll, right? That there's another one inside. If something's inside of the middle one, it's only inside of that middle one, but it's also inside of all of the other ones on the outside.
So let's say I declare the array outside in the global memory, and I go in and I use it as a parameter in a function like this one, and in the function I add something to it. However, I don't return it outside.
That is getting a little ahead of where we are, which might confuse a few folks. But I'll happy to go over it with you after the class.
Okay.
Basically, it's just asking about manipulating an array inside of the function, something that we can do. But for the purpose of tonight, don't worry about that. We're just going to live inside of this place. I'll be happy to go over with you after the class, though, how that works. So we've set grades equal to. I'm sorry, I keep doing that.
Oh, I suppose.
No, it's tight quarters in here tonight. It's my fault. So we're gonna go through this really quick. Sum equals 0. Right? Now we do our loop. Step 1. Let I equal 0. Step 2. Check if I is less than now grades dot length, which luckily is still our trusty 3. Third step is sum equals sum plus grades bracket I, and our last step I++. All right, you should all be very familiar with this by now. Who's gonna walk me through it this time? What was your name?
Michael.
Michael. Let's see what you got.
So first, I is 0, so we check if it's less than the length, which is 3. It's
Okay.
true. So we keep going. Now sum was originally 0,
Okay.
so I'm going to add the first element of the array, which is 50, so I end up with a 50.
Okay.
So now I'm going to increment the I, so now it's 1. And now I'm going to go back to the checking, which is number 2. Is it less than 3? Yes, it is. So I'm gonna, now sum is 50, so I'm gonna add the second element of the array, which is 75, so I get 125.
Okay.
Now I'm gonna increment again, so now I is 2.
Okay.
And I'm gonna check, it is indeed less than 3, so that's fine. So now I'm gonna add the third element of the array, which is 100.
Okay.
Okay. And then I add again, so I is 3. When I go back to 2, I fail. So,
And we're done.
yeah.
What's the next thing that we're going to do here? So we finished
so
our
now
loop.
I'm done with the for loop, so I'm going to return the value to, so I think it was output, so output will now be whatever that number is.
Exactly. So output is now going to be 75. So once we hit this return, this is the keyword that lets you know that we're done. Anytime you return inside of a function, it ends the function. If you had 100 lines of code after a return statement, it would never get read. Because as soon as you hit the return key, you've returned a value from your function, and it's done. So we hit return, all this disappears. Average my grades gets popped off the top of our call stack. What's the next line of code that we are going to hit? Alicia.
Clear
New output. Okay. And then what are we going to do?
And then, do we go back into let
Well, first we've got a couple of things we have to do on the board before we can go into that function, right?
Local
She's got it. She's got it.
grade is going to equal beta grade?
Well, we got to have a place to put that first, right?
Yeah, so we're going to do the global execution,
Local execution context.
and local memory.
Okay. And there's one other thing we got to do so that we know what we're working on.
Oh, the call stack?
There you go.
You're going to put average my grades in there. We'll stay there.
So that way I always know what I'm working on because it's on top of the call stack, right? So if I got average my grades, then that's what JavaScript is working on. So.
Then we're going to put grades.
Yep.
And equal it to the array that was on average my grades, which is 185.
We got different numbers this time. Finally. Okay.
Then we declare a variable sum 0.
Okay.
And then we're going to go into the loop.
Okay.
And so let I equal 0. Then I is less than grades plus dot length. Then third step is sum equals sum plus grades. I. And then I plus plus.
Okay. So how do I walk through it?
So then we're going to say I is 0.
And where do I store that?
We're going to start over there.
Right here in my local memory. Okay.
And then we're going to go to 2. Is I equal to 0 less than grades dot length, which is 3. Yes, so I 0 plus grades,
Okay.
which is now 50.
Okay.
Plus grades.
Wait. So sum is 0. So
sum is
0 plus
grades, which is 100.
100. So now we're going to say sum is 100. And then.
And then plus 1.
Okay.
So I is now 1.
Okay. And where do I go?
Then we're going to go back to, we're going to say I is I less than grades dot length. Yes, it is. So now I am now sum equals sum plus grades, which is 100 plus 85.
Okay.
185.
185.
And then I plus 1, which is now 2, and it is 2 less than the length of grade. Yes, it is. So then sum is now 185 plus 100, which is 285.
Okay.
Thank you, Lexington. She's adding to me.
You got your calculator over there.
So I is now 3.
Okay.
So we're actually going to stop because I.
Okay.
So we're done with the loop, and now we're going to return
285 divided by 3.
285.
95. We got 2 calculators. Nice. Return 95. Where do we return that to?
New output.
New output. And then this gets closed. We pop this off of our call stack, and we have ended our execution. We've come to the end of our execution context. Marcos.
Just curiosity, when you do the call stack, you're doing that just as illustrative purposes, so we can see how JavaScript works, or you can actually use it to kind of help you out when you're solving a problem, just to.
So I'm showing it to you because this is what JavaScript does under the hood.
Yeah.
As I said, there's nowhere you can go to see what this is. But JavaScript in the background, that's how it keeps track of like what's going on. Now, 1 second. It's just like, you know, like if you're like, okay, I need to remember to do all these things. You have it in your memory, but it's not written down anywhere, right?
Yeah.
So, you know, in your brain, it knows what it's working on, what's going to do next. Same thing in JavaScript. It's got this stored, this call stack, but there's nowhere that you can go to see like, what's on top of my call stack?
No, I see. But what I'm saying is like, okay, so you're doing that so we can see that.
Mhm.
But do you do that when you have to solve a problem, just to organize in your head, or not really? Just go to the
It
algorithm?
depends on how advanced the problem is, and if you feel like you need to do it. There's definitely nothing wrong. The more stuff you draw out when you're doing any kind of like problem, the easier it will be to understand and solve.
Thank you.
Yes.
Just to piggybacking on what you said, in job interview when they do like whiteboarding questions, if we go in depth the way you did in terms of breaking down the call stack and how you're going through line by line, is that prevalent to more like the entire, like meaning like if we just go with that way, the way you're saying that detail, does it show the logic behind it, or we should just say to go line by line?
You know, it really depends on what it is. When you're whiteboarding, they're not going to give you like a problem like this and ask you to explain it. They're going to give you a problem, and then you're going to have to create this code on the whiteboard. So it's...
So while you create it, can you say it the way you said it? Like
yes, 100%. Like the more you practice your technical communication, and that's why we make you guys do this over and over and over again, because this is what you have to do. And especially if you're working together in a team, you need to be able to explain to somebody. You don't just be like, you know, you do that thing and then it does that thing. Like you need to be able to know technically how to explain everything that you're doing. And that's where it gets tricky. It's one thing to be able to sit down at a computer and write the code. It's another thing to be able to, you know, confidently explain how it works to someone else. And that's what the purpose of these classes, that's why we keep calling on you and doing the same thing over and over and over again. Is to work on that. 1 second, yes?
What would be an example of a problem? Because you said they're not going to ask you to explain a code. They're going to give you a problem.
So you would never get something quite this simple in a job interview, but basically if what they wanted you to come up with is this, the question would be, how would you write a function that finds the average of an array of numbers? And then so you would say, okay, I would create a function and I would pass grades in as my parameter, and you would walk through like how you would write this function, right? And there's like a whiteboarding interview is a very specific like skill in and of itself, and we actually do a class here as well. Sometimes it's part of our hard part series on how to get hired, and the whole purpose of that class is whiteboarding through problems. So if that's something you want to like brush up on, if you're like interviewing, highly recommend come to one of those classes. They're really, really good. Will or Phil usually does them, and both of those guys are just fantastic teachers, so they're really good at kind of walking you through that. But before you can do that, you've got to learn all these steps of how to get there, right? So, any other questions on this slide and kind of like how we're working on the execution context?
Yeah, it's regarding the functions. Normally when I read page source or something like that, so I never do page source. Now, I noticed they have the function that they would call them as a parameter when they don't have the extra parentheses in front of it.
What do you mean?
Let's say whatever function that they call it, when you pass it through another function, they don't actually choose the parentheses, like you call it outside.
So they're passing a function in as a argument?
Yeah.
Ah, okay.
Yeah.
So if you do that, you're correct. So it gets a little more advanced, and I'm not sure if we get to that in our slides later, but basically saying, like here, we pass an array in as our argument, right? So grades becomes this array. But what if it was a function that we wanted to pass into our function? What if we had, like basically we have an array and we want to, or we write a function, say, that takes an array and a function. And basically we want to iterate through the array that we pass in and call the function on every single element in that array. Right? So we're doing kind of something similar here, but instead of doing this for loop here, we might say, instead of saying sum equals sum grades for each, we might have like average by grades takes grades and a function, So two parameters. And that function we could put in here, and we would call that function on each of our elements in grades as we iterate through. Instead of saying sum equals sum plus this, we would say sum equals function with this parameter passed in, or argument passed in. And that may just sound like, you might be like, I have no idea what that means. And if that's the case, don't worry about that. You'll get to stuff like that when we get back into callbacks and higher order functions as well. But just know that when you say grades up there, you're just giving it a name. That's just a parameter. At the end of the day, you can pass whatever you want in as that parameter. You can pass in a string, you can pass in an array, you can pass in an object, you can pass in another function. So there's no, any kind of data type can be an argument. And because you can run a function on any kind of data type. You might have a function that removes all the vowels from a string. So you have to pass in a string as your parameter. So that you can have, here we use an array, but you can pass anything you want into a function. Yes?
So this function works because when you call the length argument to grades, that works for an array and a string.
Mm-hmm.
If you would have passed an integer, it wouldn't have worked, right?
It would not work, right? Because length into an integer. Because I can't call length on an integer. Okay, that is correct. And that's another thing. As you learn more about different data types, you'll learn about there's different properties each data type has. So an array has a length, and a string has a length, but a number doesn't have a length. A number is just, it's a number, right? So if you want to know like the number of digits in a number, you'd have to do a couple of different things before you could get that. So every different kind of data type has its own properties that you can access. So when we say .length, we're getting, it's a property that's stored on our array. Or if we're using a string as well, it has .length. Those are the only two data types that have a length property. But that's just something that no matter, if you do it on a string, it's how many characters are inside of that string. If you do it on an array, it's how many elements are inside of that array. Yes, question?
Average my grades, why is it going in a call stack?
Why does average my grades go in the call stack?
Yeah, down. So together with the variable. So variable would be the global memory going into.
Right. So when I put it over here in my global memory, I declare my variable, but then I've got to actually run this function somewhere, right? So I need that local execution context to run it. So while I'm running that function, I can't do anything else. So basically I've said, okay, new output equals whatever this function returns. So I can't move on until I've actually assigned this a value. So in order to assign that a value, I have to come over here, open up my own local execution context, and run that function. So while I'm running that function, it's on top of my call stack. As soon as I'm finished and I hit that return keyword, I pop it off of my call stack, and I can move on to the next line of code.
So global is happening outside of the function.
Yes. So the global is just like this whole space. You can think of it in like the terms of this whole floor, right? So this whole floor is like the global execution context. And what we're doing in here is just like one function. This is like a function, right? So we're just, everything that we're doing lives inside of this box. But we also live inside of this whole floor, which lives inside of this whole building. But each context is in the confines of what it is. Does that make sense? Does that answer your question? Yeah?
So the call stack is just like a reference. So whenever you want to run that function, you have to go back to that reference in the call stack.
It's just basically like, it's kind of like having like a calendar, or like I said, a to-do list. So you have your to-do list, like, okay, today I'm going to do this, and then I'm going to do this, and then I'm going to do this. But you might at some point like add something like, ooh, I need to do this also, and you add that, right? But here in a call stack, you can only do one thing at a time. So you always know what you're doing. If you have to add something to your stack, you put it on top, and you do that first. Anything that your JavaScript is always running, whatever's on top of your call stack. As soon as you pop something off of that call stack, it goes to what's ever underneath it, which is now on top of the call stack.
I was gonna add to it, but I think you might do an I remember an article from Medium. You're right about like the call stack, but if you wanted to change the order of it, you could use set timeout.
Right, which goes into a whole other kind of like set of things, and we get into that more in our things. But that actually, set timeout has nothing to do with JavaScript. Set timeout lives within inside your browser.
Oh, wow.
And so basically, that's something where you're telling JavaScript, hey browser, go do this while I continue on. But once again, that is definitely a few steps after where we are now. So we'll touch into that in the JavaScript, the hard parts as well.